Okay, I've had some questions about how do we find the E matrix when we're doing state feedback or output feedback. So let's look through some of our examples that are on the web and talk about the E matrix. So this is state feedback example 3. We have our A and B and C matrices here. The A is not in Jordan form, but you can still go ahead and do the work. And so we go through, we find our psi matrix. For state feedback, psi is just phi times b, and again phi is lambda I minus A inverse. So we went through that work. We found our psi matrix, and in this case, since B and C are 2 by 1 and 1 by 2, we're getting this, or anyway, since B is 2 by 1, we're getting our psi matrix has only one column. And so to make G, remember to make G, we take a column of psi and put in the desired eigenvalues. And so since there is only one column of psi in this example, then we put the first column in both places for G. Remember, G has to be a square matrix because we need to take its inverse. E, remember, we just form E by putting in the natural vector, the E, the small lowercase e, that with a 1 in the position corresponding to which column of psi we're using in that corresponding position in G. So since the first column of G has the first column of psi, our E vector is 1. Okay, and similarly, the second one is also the second column of G also uses the first column of psi, so this is also E1, and so we have a second 1. Okay, and since the dimensions of the problem are such that E is only a 1 row vector, we only have a 1. If this was a 2 by 2, we'd have a 1 0 1 0. If it was a 3 by 3, we'd have a 1 0 0, so forth. It would be a unit vector with 1 in only one position, zeros everywhere else. Okay, let's look at well, continuing this example then, to find K, you take negative E times G inverse and continue through the problem. Let's look at example 4. Okay, have a little bit different system, or maybe it's the same system. Different required eigenvalues. Well, our B is different. Our B is now 2 by 2, so when we calculate our psi matrix, B times B, we're going to have a 2 by 2, so now we do actually have two different columns we could use. We're going to build G. Here we're going to use first column of psi for the first column of G and the second column of psi for the second column of G. Okay, and we're putting in the first eigenvalue and the second eigenvalue for the different columns. And so that means E is kind of like taking an account of what we did to build G. So for E, since we use the first column of psi, we have a natural vector with a 1 in the first position, 1 0. Here we use the second column of psi for the second column of G, so we have a 0 1 with a 1 in the 2 position. Okay, so we're looking at the index of psi we use here corresponds to which natural vector we use. Psi 2 here, so we use the second one here. Okay, and so we have our E is the identity matrix then, and when we go through and take the inverse, calculate it, we get our K. Let's look at the next example. State feedback, example 5. We have a 3 by 3A. B is 3 by 2. Same process. We find our B matrix, lambda I minus A inverse, and we calculate psi. This time psi again has 2 columns. For this one, we are asking for a desired repeated eigenvalue, and so we're looking to build our G. If we take our first column of G as psi 1, and then we try to do our repeated eigenvalue, we'll do the derivative, and we'll see that we'll come up with things that are not linearly dependent. So we try a different one. And so for this first one, we would have had 1 0, or for E we would have had a 1 0 corresponding to the first column of psi, and then a 0 1 corresponding to the second column. When you do the derivative, you just put a 0 0. But this one didn't work, so anyway, we're not doing that. We'll go to the second one, try it the other way, put the second column of psi in for the first column of G, and then the second column, or the first column of psi and then its derivative for the repeated eigenvalue to build our G, and that works out as being linearly independent. And so our E becomes 0, 1 because we use the second column of psi first in G, and then 1, 0 because we use the first column second. And then the third column of G is the derivative, so it's a 0, 0 when we put it into E. And again, we can calculate our K. Let's look at an output feedback example. Here we have output feedback example 1. And now when we calculate psi prime, we have a C in the calculation, so C phi B. And so we have a similar kind of process, but just a little bit different equation for calculating psi prime as opposed to psi. These should be primes. Alright, so we get our psi matrix here, 2 columns, 1 row. And so when we're calculating our G prime, it looks like in this one we're only setting 1 eigenvalue. Anyway, the dimensions of the problem come out that G is only a 1 by 1. We only need the first column of psi. Looks like the simplest was psi prime. We put prime in here. And so we use the first column, and so our E is a 1, 0. We could have done a little bit with the dimensions here. But to get the K prime to be the right size, we need the E prime to be a 1, 0. And so then when we multiply things out, we get our K prime. Oh, it looks like that didn't work, so we're going to try the other, since with output feedback, we can set one eigenvalue, but we can't set both, and so we moved it, but then the other one was still unstable, so we're trying another one. So this example has 2 examples of E. For calculating G prime the second time, we're going to use the second column of psi, and so our E prime then is 0, 1, representing the second natural vector, second column of psi used in making G prime. And so we go ahead and do that. Yet another example. What happened? We still didn't get the, okay, we did get it, but we're going to go ahead and do another calculation. We're going to add another output, so our psi prime now is 2 by 2. And so when we build G prime, we're going to just do the first column in the first position, second column of psi in the second position, and so we get a 1, 0, 0, 1 for E prime. Again, same kind of process. Let's look at the output feedback example 2. Again, we build our psi prime, C, B, B, and go through the dimensions. K prime is going to be 2 by 2, G prime M by M, so it's 2 by 2, and E prime is also 2 by 2. So we've chosen then our psi 1 as our first column of G prime and our psi 2 column as the second. So our E matrix, our E prime matrix, then becomes just the identity 1, 0 for the first, represented first column, second column.